Tutorial number 2, Deploy an Image Classification Model in Azure Container Instance, ACI. This tutorial is part 2 of a 2-part tutorial series. In the, you train machine learning models and then register a model in your workspace on the cloud. Now, you're ready to deploy the model as a web service in ACI. A web service is an image, in this case a Docker image, that encapsulates the scoring logic in the model itself. In this part of the tutorial, you use Azure Machine Learning Service, Preview, 2. * set up your testing environment. * retrieve the model from your workspace. * test the model locally. * deploy the model to ACI. * test the deployed model. ACI is a great solution for testing and understanding the workflow. For scalable production deployments, consider using Azure Kubernetes Service. For more information, see Prerequisites. Complete the model training in the notebook. This code registers a model named sklearn_nist in an Azure Machine Learning workspace. It also creates an environment called tutorial env with the necessary dependencies for the model to run. Set up the environment. Start by setting up a testing environment. Import packages. Import the Python packages needed for this tutorial. This code is used to display the version number of the Azure ML SDK. Deploy as web service. Deploy the model as a web service hosted in ACI. To build the correct environment for ACI, provide the following. * a scoring script to show how to use the model. * a configuration file to build the ACI. * the model you trained before. Create scoring script. Create the scoring script, called score.py, used by the web service call to show how to use the model. You must include 2 required functions into the scoring script. * the init function, which typically loads the model into a global object. This function is run only once when the Docker container is started. * the run, input_data, function uses the model to predict a value based on the input data. Inputs and outputs to the run typically use JSON for serialization and deserialization, but other formats are supported. This code is a Python script that defines 2 functions, init and run. The init function initializes a global variable named model by loading a pre-trained machine learning model from a file specified by the model_path variable. The file is expected to be stored in the Azure ML model directory. The run function takes in raw data as input, presumably a JSON-formatted string, and performs the following steps. 1. Converts the raw data into a number py array using the json.loads function. 2. Uses the pre-trained model to make predictions on the data. 3. Converts the predictions into a JSON serializable format, a Python list, and returns it. Overall, this code can be used as a scoring script in an Azure ML deployment to serve predictions from a machine learning model. Create configuration file. Create a deployment configuration file and specify the number of CPUs and GB of RAM needed for your ACI container. While it depends on your model, the default of 1 core and 1 GB of RAM is usually sufficient for many models. If you feel you need more later, you would have to recreate the image and redeploy the service. This code deploys an Azure Container Instance, ACI, for a web service using the Azure Machine Learning Service. It specifies the CPU cores and memory for the ACI, sets tags for the deployment, and provides a description for the web service. Deploy in ACI. Estimated time to complete, about 2 to 5 minutes. Configure the image and deploy. The following code goes through these steps. 1. Create environment object containing dependencies needed by the model using the environment file, mynv.yml. 1. Create inference configuration necessary to deploy the model as a web service using * the scoring file, score.py. * environment object created in previous step. 1. Deploy the model to the ACI container. 1. Get the web service HTTP endpoint. This code deploys a trained scikit-learn model for image classification to Azure Machine Learning as a web service. It creates an Azure Machine Learning workspace, loads the trained model, creates an environment configuration, and deploys the model as a web service using Azure Container Instances. The code also includes timing information to measure the deployment time. Get the scoring web service's HTTP endpoint, which accepts REST client calls. This endpoint can be shared with anyone who wants to test the web service or integrate it into an application. This code prints the scoring URI of the service variable. Test the model. Download test data. Download the test data to the /data/ directory. This code is responsible for importing necessary libraries and downloading the NIST dataset from Azure Machine Learning. It creates a folder called data to store the downloaded dataset. The code uses the NIST class from the Azure ML.OpenDatasets module to retrieve the NIST dataset and then downloads it to the data folder using the download method of the dataset object. Load test data. Load the test data from the /data/ directory created during the training tutorial. This code imports necessary libraries and defines the data folder path. It then loads the test images and labels from the specified data folder and rescales the intensity values of the images to a range of 0 to 1. Finally, it reshapes the labels into a compatible format. Predict test data. Feed the test dataset to the model to get predictions. The following code goes through these steps. 1. Send the data as a JSON array to the web service hosted in ACI. 1. Use the SDK's Run API to invoke the service. You can also make raw calls using any HTTP tool such as curl. This code converts a variable called x_test to a JSON string, encodes it as bytes, and sends it as input to a service called service, which will then return a prediction called y_hat. Examine the confusion matrix. Generate a confusion matrix to see how many samples from the test set are classified correctly. Notice the misclassified value for the incorrect predictions. This code computes and prints the confusion matrix and overall accuracy of a classification model. The confusion matrix shows the number of correct and incorrect predictions for each class, while the overall accuracy gives the percentage of correct predictions across all classes. Use matplotlib to display the confusion matrix as a graph. In this graph, the x-axis represents the actual values, and the y-axis represents the predicted values. The color in each grid represents the error rate. The lighter the color, the higher the error rate is. For example, many 5s are misclassified as 3s. Hence you see a bright grid at 5, 3. This code generates a confusion matrix plot for a classification model. It first normalizes the diagonal cells of the confusion matrix to prevent them from overpowering the rest of the cells when visualized. It then creates a figure and subplot, plots the normalized confusion matrix using a color map, sets the tick labels and color bar, and adds labels for the x and y axis. Finally, it saves the plot as an image and displays the plot. Show predictions. Test the deployed model with a random sample of 30 images from the test data. 1. Print the return predictions and plot them along with the input images. Red font and inverse image, white on black, is used to highlight the misclassified samples. Since the model accuracy is high, you might have to run the following code a few times before you can see a misclassified sample. This code first selects 30 random samples from a test set. It then converts these samples into a JSON format and predicts their values using a deployed model. Finally, it compares the actual values of the samples with the predicted values and displays them in a grid, highlighting any misclassified samples in red. You can also send raw HTTP requests to test the web service. This code uses the requests library to send a post request to a specified URL. The request sends input data in JSON format to a scoring URI. The input data is a random row from the test set. The response from the API is then printed, which includes the predicted label for the input data. Clean up resources. To keep the resource group and workspace for other tutorials and exploration, you can delete only the ACI deployment using this API call. This code likely calls a function or method called delete on an object named service. The purpose of this function is to delete or remove something, although the specific details of what is being deleted would depend on the context and implementation of the code. If you're not going to use what you've created here, delete the resources you just created with this quick start so you don't incur any charges. In the Azure portal, select and delete your resource group. You can also keep the resource group, but delete a single workspace by displaying the workspace properties and selecting the delete button. Next steps. In this Azure machine learning tutorial, you use Python to set up your testing environment. Retrieve the model from your workspace. Test the model locally. Deploy the model to ACI. Test the deployed model. You can also try out the